Hello and welcome to day 22. My USB hub died like right as it started apparently and didn't record anything. So I'm just going to start walking through the answers instead. All right. So if you wanted to read the problem description, of course, it's not additive code. But basically the prompt is we have this map and we have some sort of directions. So we start here and we're going to move 10 spaces until we hit something. Then we're going to turn right and then we're going to move 5 spaces and then so on. We're going to do that over and over. For part 1, if we run off the edge of the map, we're just going to wrap around in the same spot. No problem. So with our standard input, it's just bigger. So it's 200 rows. It's basically 200 by 150 instead of like 10 by 15 or whatever it is. And much longer instructions. So the first thing we do, as always, is get our input. I already have a helper function to grab a input based and break it on empty lines, which is what they give us between our two pieces of input here. So this is going to give us a list of strings. The outer list is going to contain 2 elements. The first element is a list of all of these, and the second one is a list of just this one long string. To get the map, easy enough, we're going to just basically iterate through each of those lines and then each of those characters in those lines and then throw it into a 2-dimensional array, 200 by 150, and then no problem. And then in the instruction portion, I just put a regex in here. So this is going to pull out all the numbers in here, so 9 to whatever. And then this one's going to pull out all the letters, so which are just right and left. And then I'm going to add all those into 2 lists, basically. And then we're going to start at the top coordinates, and while distance is not empty, and then just so you know, like the distance always starts with our distance marker, then a direction, then distance marker, and the last one does not have a direction marker, just a distance. So we'll do the break on the distances basically. So while the distances aren't empty, remove the first one, and then whatever that number is, if it's 10, we're just going to move 1 space 10 times. And if we hit a brick right off the bat and we spend 9 times spinning our wheels, totally fine. It's a small enough input. Who cares? And then if directions is not empty, which is basically going to be every time except for the last, then we're going to turn one direction or the other. Since they give us the coordinate or the directions as 0, 1, 2, 3, basically with right we can just +1 and mod 4, left we can +3 and mod 4. Just makes it simpler. And then all of the actual logic for moving 1 step happens in the map.next function, which takes in your map, your current position, and your direction, and returns a new position. And so basically it's going to take the next x and next y is equal to the current position, and then depending on which direction we're going to either increment or decrement one of those. If we run off the edge of the map, then we need to wrap around to either the end or the beginning, whichever is the case. And if it's a space, while it's a space, then we're going to do the exact same thing over and over again. So basically, if we, move, like right here, we're going to keep moving right 50 more times until we run over here. And then we're going to move right 50 more times until we hit this. A little bit of a waste, but again, small enough input, it runs pretty quick. And once we find the new coordinate, if that new coordinate is a rock, then we return our current position. We just don't move. If that new coordinate is not a rock, then we return that new set of positions. So basically, that's it. So we basically just run through that list as many times as we can, sort of run out of inputs, and then put the input in the format that they want, output it, no big deal. For part 2, things get a little weird, as has been the case recently. So this is not considered a flat map anymore. This is a cube. So like this would be like, say, the top, this would be the front, this would be the left, this would be the back, this would be the bottom, this would be the right, if you kind of can fold it up in your mind. Unfortunately, the input is a different setup. So they use a different folding mechanism. Rather than trying to just make one that generically works, I just use the one from my input. I don't know if everyone's is going to be the same, but that's what I did just to make it easier for me. I just did the one. And basically what that looks like from mine is this coordinate. So I have basically, again, think like this would be the top, this would be the right, this would be the front, this would be the bottom, left, and back. And so the input functions are exactly the same. We're going to take in our array exactly the same way we did before. We're going to take in our distances and directions exactly as we did before. We need to change our starting position because we no longer have the freebie, just keep moving to the right. So I have to actually go find what that is, but I just manually programmed it because I'm only running it on the input. And then same loop as before, while distances is not empty, pop the first one and get the new coordinates. And then if directions is not empty, pop that one, you get the new direction. And then the only difference here is that this loop, we also return back the new direction coordinate, and we use a different call to get that. So if we go into map next queue, and this is probably why you're here, this is the same kind of thing, takes in a map, a current position and a direction, and now instead of returning a pair, it's going to return a triple, which is your X, Y, and new direction. So a couple of things to think about and how to do this. So the first is I made a kind of a flat map cube here, and I also put ranges in for these. So you're thinking like this is being YA, YB, YC, this is XA, XB, XC. So I can make these ranges up here. So instead of trying to remember the math, I can just say if it's an AA, then I just say if it's an YA and XA. Makes it way easier. And then the first part of it's going to be exactly the same. We're going to traverse as we normally do. One thing on that, I don't know if this is going to be the same for everybody. It's definitely the same for mine. But like 4, if I move to the left, it's a blank space. 6, if I move to the left, down, or right, it's a blank space. 3, blank space. So if I run off the edge, it's always a blank space. Secondly, if you don't run off the edge, if you keep in this pattern, everything is exactly the same as it was before. So if I now hit a blank space, that means I need to move faces. Basically, to make this a little bit easier, I drew this out on paper first, and then for each face, I labeled them in this direction as they are already, so I know which way is up and which area they're in, AA, AB, whatever. And then I cut it out and I turned it into a cube. So to kind of walk you through one of these, let's look like the first example here. So if you're on face 1 and you're moving up, then let me get that into focus here. So if we're on face 1, which is at position AB, if we're moving up, then basically we're going to go this direction. And if we go this direction, that's 6. But you'll notice 6 is basically new direction. So not only am I have to figure out what this new coordinate is over here, but I also have to update the direction to be going right, not up anymore. So basically our next X is going to be here on this edge, and 6 happens to be on the left edge, so that new X coordinate is always going to be 0. The Y coordinate is going to be different though. It's going to be dependent on the X coordinate here. So however far you move along, the X value here is how far up and down you move on the 6 over here. So basically once we do those checks, is like basically were we in the one face to begin with, and did we run off to the upside basically. That means we need to move to 6. And then I just update those coordinates for the new X, the new Y, the new direction, and then I do it again for every other combination. So a couple of tricks to get you through here. First, as I said a few minutes ago, if you run through this direction, everything is exactly the same. The orientations are the same, the coordinates are the same. You don't have to worry about changing anything. So how that works on your cube is places you had to put tape, you need to put cases for. Places you did not put tape, so like for example here, 1 to 3 is exactly the same. So these are still flat. If I run off here, the coordinate is still the same, the direction is still the same. And the same if I run to 5. And the same if I run to 4 from there. So in those cases, the direction is going to stay the same as it did the first time. And then for everything else, write a case for it. And then another helpful thing is just go ahead and put your debugger on every single one of these cases. And run debug, and then whenever you hit one, step through and make sure that the coordinates actually make sense. They're actually in the place that you want them to be. If they don't make sense, obviously fix them. Every time you see when that works, go ahead and turn off the debugger for that. When you're done, you're going to end up probably with one or two cases that you didn't hit. Those are probably places where your check is wrong. It should hit every single one of these. At least in mine it did, and I assume based off the way they usually do these things, they're going to check every single coordinate, or every single transition, I should say. So if you go through here and one of them never gets hit, check your conditions because you're probably just missing it. Other than that, this is all basically the same. And then we get to the end, we check the new position. If it's a rock, again, we just don't move. And if it's not a rock, then we return the new X, Y, and direction now. And then the actual output, everything is exactly the same as what was before. All that is identical. And again, a little bit of wasted time, but it's small enough that it runs, 13 and 16 milliseconds. Nobody's going to complain. So anyway, that is it for day 22. 3 days left. If you have any questions or comments or anything, of course, hit me up in the comments below. If you want to check the code in more detail, it's always up to date on GitHub below. And then other than that, I will see you guys tomorrow.